This is AP Calculus, section 7.3, page 3. We are going to be starting looking at another way to find volumes, and we are going to be using the washer method. Forgot to get my pens set up here, so I just had to get them. All right, a little Home Depot lesson. We have a bolt and a nut that screws on the end of the bolt, and a washer that helps hold things tight. And what's nice about seeing this little Home Depot lesson is that washer is just like our discs. A quarter is an example of the disc method, that when we're slicing through we have solids. A washer is just like that disc. The only difference is it has a hole in the middle. So that's what we're going to be looking at today. If we just trace this washer, we will be looking at trying to find the area of the solid part of that washer. This washer has two radii. It has a radius that goes from the center through the emptiness just to that inner ring. Let's call that little r. And we have this radius, the larger radius, which goes from the center to the outside of this. Let's call that big R. And we are looking to find the volume of this washer. I forgot to write down, a washer is a disc with a hole in it. So when we want to find the area of that washer, we find the area of the whole circle, and we're going to subtract off the area of the little circle. The area of the big circle is pi times its radius, or big R squared. The area of the little circle is pi times its radius, or little r squared. And factoring out a pi, that's the formula that we will be using to find the area of each of those individual washers, and then we multiply by the thickness just like we did yesterday for disc. To look at this first problem here, to find the volume of this solid that's created when that region enclosed by 6 minus x squared and 3 minus a half x squared is revolved about the x-axis. We do need to sketch a graph. Very often I like to sketch these graphs in pencil first, and then I'll go back later once I know the shape that I'm talking about and kind of darken them up in a different color. So y equals 6 minus x squared, that's a parabola opening down. Vertex is at 6, so we have this going on. And we know it hits up here at 6, and we know the x-intercept. We have the positive square root 6 and a negative square root 6. And going ahead and graphing this second parabola, clearly opening down, vertex is up at 3. If we take this and solve for the x-intercepts, then we have 3 is a half x squared, or x squared is 6. So this second parabola has the same x-intercepts. It's a little wider though. So we have something like this. There's the shape that we're looking for. And the region that's between those two is this. All right, now, these kind of extensions of that parabola, not necessary, so I am going to go back and erase those out. And I'm going to go ahead and darken up in a different color kind of my two different parabolas. So this 6 minus x squared I'm going to put in red. And this 3 minus a half x squared I'm putting in blue. All right, this is the region that we want to spin around the x-axis. So this shape right here is coming up and around this way. To draw that, we're just going to copy this right underneath. Generally, when I copy underneath, I do that graph a little bit lighter. It's hard to see that 3 dimensions right now, but if we go ahead and put in a representative slice. Now, because this was spinning out and around, here's our washer. This is really sitting like this. So there's a hole in the middle right here. Can you see the pencil going through? There's a hole in the middle. So to draw this slice, we'll draw an oval and thicken up one edge. Draw another oval. I think that might be hard to see. Let me do this in pen. And thicken up an edge of that one. So we have kind of this oval on the cutout, or the inside, the emptiness. And we have this oval that's on the outside edge. There's that washer standing up. Can you see the 3 dimensions now? You should hopefully see this coming out of the page. To find the volume, now we know we're going to have to do a washer because there's emptiness in the middle here. This is all empty. And when we find volume using a washer, volume is add up a bunch of these washers, so pi times big radius squared minus little radius squared times thickness. That pi can come out. Now the big radius, that radius goes from the axis of revolution all the way up to the outermost edge. So that's big R, and that is a y value to the red parabola. So I'm going to say y to the red, and we have to square that, minus then the inside radius, or the little radius, goes from the axis of revolution through the emptiness, so that goes up to the blue parabola. It is a vertical distance, so it is y to the blue parabola, and we're going to square that. And then times thickness. Now if I put this washer in here, and if you wanted to measure how thick across this washer is here, that's our horizontal distance, so our thickness is dx. Okay, we need to have all x's in here, so I have to trade out that y to the red parabola. So we have 6 minus x squared minus y to the blue parabola, 3 minus a half x squared, quantity squared, all of that dx. Okay, we need bounds here. Bounds are where you start slicing to where we stop slicing. And the first slice is way over here at the edge, which is at negative square root 6. And then we slice through until we get to square root of 6. So you could say bounds from negative square root 6 up to positive square root 6. But also notice that the slices between negative square root 6 and positive square root 6, negative square root 6 all the way up to 0, those slices repeat themselves from 0 to pi over 6. So we could just find half of the slices, so go from 0 to square root 6, and then double it. There's the volume. And you can absolutely just type this right up in your calculator. You can put the 2 pi first before you access FNINT. And when you type that in, you should get 70.545 pi if you didn't multiply out the pi, or if you did multiply out the pi, 221.625. Please verify that you can type that properly into your calculator to generate these answers. Okay, looking down to this next problem. Find the volume of the solid that's created when the region enclosed by x equals y squared plus 1 and y equals x minus 3 is revolved about the y-axis. Again, we need to sketch a graph here. Okay. X equals y squared plus 1. Let's solve for y, so subtract the 1. And then square root both sides. Y is plus or minus the square root of x minus 1. That takes this square root of x graph, which looks like this, and it's going to shift it 1 unit to the right, so we have something like this. Again, I am going to go ahead and sketch this in pencil first, and then I'll go back and trace them out a little darker if I need to. And then we also have the negative square root, so we have this piece down here. There's that one, and then now let's do y equals x minus 3. It's 1, 2, 3. We have something like that. If you did not make your parabola large enough, you may not see this point of intersection up here. You are going to have to extend out that parabola to make sure that these lines, or the parabola crosses this line. But now, looking at my graph, the region contained between those two is this right in here. All right, I am going to go back and erase out those extra pieces. We don't need this piece down here. We don't need this piece here. Usually I leave a little bit left over, but not so much that as I had before. All right, let me go back then and darken up some things here. Let's put this parabola, this sideways parabola, I'm going to put that in blue. And this line I am going to put in red. That's this region. And we are going to have to take this region and spin it around the y-axis this time. So we are spinning this way. So we'll need to copy that onto the other side. Over here. All right, now we can't see 3 dimensions very well right now. Let's go ahead and draw in some ovals. It's spinning out and around this way. kind of the top edge coming around. Bottom edge. I have a bowl here. It's kind of a bowl that's got stuff stuck to the sides, if you will. It's kind of sticking out, but it didn't stick all the way down to the corners. And if we put a representative slice in here, we're spinning out and around the y-axis. So our slices are going to go through this way. Hopefully you can see this slice. If you can't really picture what's going on, please talk to your teacher, see if he or she can explain it to you. All right, there we go. And our washer, here's our washer, is sitting like that, just like this in here. All right, emptiness in the middle. Let's find this volume. So we know we're doing a washer again. Volume is pi, I'm going to pull that pi out right away, times big R squared minus little r squared times thickness. Big radius goes from the axis of revolution all the way out to the outer edge. Now that distance, notice it's running horizontally. That is an x value. So we are going to have an x value, and it's the x value that goes to the line. If you want to write it to the red line, that's fine, but it goes to the line, and we have to square that. Minus, now let's do the inside radius with the little radius. The little radius goes from the axis of revolution to the parabola, and it also is a horizontal or an x distance. So this is an x distance, but it goes to the blue parabola. And we have to square that as well. All right, thickness. Again, if you want to measure how thick this is, you would be measuring vertically. To measure how thick this is, you would have to measure vertically, and that is a change in y values. So your thickness here is dy, which means in here we have problems with these x's, so we need to have them in terms of y. So for the line, in order to put y's in here, I have to solve for x. X is y plus 3, so the line's going to be y plus 3 quantity squared, minus, now x to the parabola. Well, we already have that. That's y squared plus 1 squared. All of that dy. Okay, bounds from where we started slicing on the bottom up to where we stop slicing on the top. So we need that point of intersection and that point of intersection. So that is where the parabola and this line intersect. And if we look at this, we have x equals y squared plus 1 and y equals x minus 3. Could we just take this x, which is y squared minus 1, and come over here and replace out that x with the y squared minus 1? So we have y equals x, which is y squared plus 1, and then minus 3. We have y equals y squared minus 2. Quadratics, let's pull this y over. So 0 equals y squared minus y minus a 2. That factors into y minus 2 times a y plus 1, which means y is 2 or y is -1. All right, which means that this point of intersection right here is something, comma, -1. And this point of intersection up here is something, comma, 2. And to be honest, we don't even really care what those x coordinates are for the point of intersection because our bounds have to be y bounds. So this lower y bound, -1, upper y bound is 2. And there you go. And you can zap this in your calculator, and I believe we come up with 64 pi over 5. I'm going to have to run and check that really quickly because I put my answer across the room. So hold on one second. I think I'm right with that, but let me see. Oh, it's a good thing you waited for me because I was wrong. The answer is 117 pi over 5. I must have been remembering an answer to a different problem. Sorry about that. Oh, thank you. Please join me on page 4.